Good day, good day. We are continuing with the questions of equilibrium. So on this question, they say that if the mass of the cylinder, I hope it is visible enough. I say that if the mass of the cylinder C is 40 kg, determine the mass of the cylinder A in order to hold the assembly in positions shown. So in this case, what are we going to do? We are looking for the mass. We have the mass of the cylinder C. We are looking for the mass of the cylinder B. So in order to see my face, here I am. We're going to look into this question right now. So the first thing that we need to do is to draw the free body diagram, right? We have a force that is going like this. We have to draw a free body diagram for body A and body B. So we have a force that is going like that, which is tension EB. And please look at something. At the body B, there is no friction, which is body C. At body C, there is no friction. So tension at EB and tension at BC is going to be the same. Okay. Right now, let's just draw the free body diagram first so that we can attack. We only have mass. Let's just draw the free body diagram first. This is the tension of EA, and gonna draw the tension of ED. It's going to look like this. Little bit upward. Okay, I think it's fine like this. Right now we can name our forces. Here we have TEB. Here we have TEA. And here we have TED. Okay. And okay, this is for body A. For body A. But what I like to do mostly, in order to answer these questions, you need to do what? You need to show the vertical and the horizontal component. So this dotted line or the imaginary lines are going to represent what? Are going to represent the what? Are going to represent the component of the forces, right? Okay. Therefore, here we have a vertical component, and we need to show a horizontal component also, which is going to be like this. Yeah. Fine. Here, this vertical component, we can name it. We should name it. We will name it. We will name it what? TEB. TEB. Sine 30. This horizontal component, we're gonna name it TEB cos 30. Therefore, I think we are done with our diagram. We can go. This is the diagram for body A. And we also know at pulley B at pulley B, there is no friction. Therefore, okay, let's go to the questions straight right away. We at pulley B, there is no friction. Therefore, TE TEB is equals to TBC. Yeah. How do we get TBC? TBC, we know who is going to be TBC is going to be WC is equals to mg, right? Therefore, we have the mass, which is 40, is going to be 40 multiplied by 9,81, which is going to give us, take the calculator, 40 multiplied by 9,81. It is giving us 392 Newton. Fine, that is that. And we also have the angle here, which is 30, right? This angle is 30. We're gonna go to the summation of the vertical forces, right? We're gonna go to the summation of the vertical forces. We know the summation of vertical forces is equals to 0. We take up what? That's the positive direction. Fine. Therefore, we have what? We have TEB sine 30 minus this force. Let me highlight it. This force. Because of we took the upward direction as positive, this force is going to be negative. Negative what? Negative TEA. The T, it represents the tension, is equal to 0. We only have two forces here. Therefore, we're gonna call this equation 1. Fine, that is that. And we also said TBC is equal to TEB because of there is no friction. Therefore, we calculated the TBC. It means we calculated TBC. We did calculate BC, the tension on BC, which is 390, we're gonna say, but TEB is equals to TBC is equals to 392 Newton. Okay. Therefore, we can substitute TEB into equation 1. We're gonna substitute this TEB, which is 392 Newton. Therefore, we're gonna have our equation 1 is TEB sine 30. Therefore, it's gonna say we're gonna have what? We're gonna have 392. This 3 does not want to look nice, man. 392 sine 30. Let's transpose this TEA, this side, TEA. Therefore, our TEA is going to be, let's punch the calculator. Our TEA is going to give us 196,2 Newton. Okay, but we are not done. We know tension of EA is equals to mg. The mass of A is equals to TEA over G, which is going to be 119,62 it is 196, not 19,62. 196 over 9,8. Therefore, we're gonna get let's calculate 196,2 over 9,8. Therefore, our mass of A is 20 kg. If you are given that you should draw the free body diagram for if you are given that you should draw the free body diagram for the body of B, let's just draw it fast. Let's just draw it. Yeah. If a question arises that you should draw the free body diagram for body C, we're gonna have TBC here. We're gonna have another one TAB like this. TAB is gonna look like this. Fine, but they need to join each other. They need to join each other nicely. I think it's fine like this. Therefore, we're gonna have our imaginary line representing what? Representing the component of the forces, which is going to be like here, which is going to be here. Fine. We're gonna name our forces. This is for body. This is for what? Body B. That one is for body A. This is TBC. This is going to be the T. This is TEB. If you are given to draw it, so that is that. If you are also advised to draw what? To draw the force of polygon. Okay, let's draw the force of polygon, guys. Gonna draw it here. I'm gonna use it my freehand force polygon. Let's draw it. Gonna have one force that is going like this, another one that is going like this, another one that is going like that. Okay, this is TEA. This is T. This is going to be TEB. This is going to be FTD. That is that. Your scale is going to be 1 centimeter, is equal to 100 Newton. That is that, guys. I hope you understood, and everything is clear. If you have another problem, we're gonna do it together. I thank you, guys.